Hey everyone, and welcome to The Explainer. So, if you're a developer who has ever just wanted to pull your hair out because an AI confidently hallucinated a brand new API or totally failed to use modern syntax, well, you are absolutely in the right place. Today, we're going on a deep dive into Skill3. It's this incredibly fascinating tool that acts as the ultimate local solution to the LLM knowledge cutoff. We're going to break down exactly how it works, why it matters, and how you can actually use it to keep your models grounded in the present day.
To really get why Skill3 even exists, picture this. What actually happens when you ask an AI about something created after it was trained? It's a lot like talking to a brilliant time traveler, or, I don't know, an expert who's literally been living in a cave since their training ended. When you ask them about new tech, they don't just politely say, hey, I don't know. Instead, they confidently hallucinate. They guess how they think an API should work based on old, stale patterns. They are completely frozen in time, basically just guessing the future.
Okay, let's dive into this. Here is our roadmap for today. We'll start with the knowledge cutoff problem, introduce Skill3, and then trace a single query through the discovery pipeline, synthesizing the delta, and finally, vetting for safety. Let's get right to it.
Part 1. The knowledge cutoff problem.
So a knowledge cutoff is a hard property of an LLM's training. It literally marks the exact fixed date its knowledge of the world simply ends. And it's super critical to understand that this cutoff isn't some software bug waiting to be patched, it's a structural reality of how the model was built. For instance, take a highly capable model like Claude Opus 4.8. It freezes in January 2026. If you ask it about anything from February 2026 onward, it just misses it, and you can't just magically retrain the model on the fly.
Let's make this concrete and look at how this stale memory actually breaks things in the real world. Take the Model Context Protocol, or MCP. MCP revisions are date-versioned, and changes aren't always backward compatible. There were mid-2026 updates that introduced the stateless release candidate, dropping session headers, changing the handshake, the whole shebang. But if you use a pre-2026 model, it confidently spits out the old protocol. It hallucinates old transports, misses the new required headers, and then completely silently breaks your real integrations. And as we all know, that usually happens at 2 a.m. on a Friday, right? This is that exact post-cutoff drift that makes building reliable AI agents such a huge headache.
Which brings us to part 2, introducing Skill3. Now, the absolute core invariant of this software, the rule it lives by, is this. A generated skill is a post-cutoff delta, not a primer. Skill3 is designed to deliver a highly targeted news briefing of exactly what the model missed. The model already knows the foundation of the topic, up to its knowledge cutoff. Re-explaining those basics, that's just wasting context tokens and processing time. So Skill3 only gathers what changed after the cutoff and compiles that into a scale the agent can load at runtime.
So how does it actually pull this off? Let's walk through the 4 steps of the pipeline architecture. Think of this as our mental map for a day in the life of a query. First, the system plans the searches. Second, it discovers the sources. Third, it synthesizes the skill. And fourth, it vets that skill for safety. It's this really elegant, completely linear pipeline where every single stage either enriches or filters the data.
Let's move to Part 3, the discovery pipeline. What's really amazing here is that discovery is completely topic agnostic. Absolutely nothing is hard-coded per topic. Instead, the synthesis model itself acts as a query planner. Since the model already understands the foundational topic, it expands your request into up to 6 distinct post-cutoff facet queries. Like, if you ask about a protocol, it's going to naturally search for spec releases and security updates. Then, the pipeline fetches these pages concurrently via virtual threads using the Brave Search API or, and this is super cool, if you want a totally offline, network-free discovery process, you can literally just use the ajadoc-input file flag to supply a curated corpus file yourself. And this brilliantly illustrates how Skill3 ensures it only finds relevant data. It uses a super strict cutoff-anchored freshness window. It totally ignores years past so you don't get redundant information. And crucially, there's an upper bound that drops any sources dated after today's run. Any future dated page is immediately recognized as a leak or a misdated file, which guarantees that only valid, temporarily accurate evidence makes it through.
Now, what's really interesting here is that not all fresh data is treated equally. The authority score lets you configure trust multipliers. So official documentation gets a perfect 1.0 trust multiplier. Standard repositories like GitHub, they get 0.7. But unverified blogs on dev.to or Medium, those drop way down to 0.2.
What this means in practice is that a post-cutoff authoritative source will always drastically outrank a content farm. It guarantees the model is learning from the actual official specs.
Okay, moving right along to part 4, synthesizing the delta.
Synthesis happens completely locally by default. It runs right through an OpenAI-compatible endpoint, meaning you can just fire up a local Llama model. You can definitely swap this to Claude or hosted providers if you want, but the real magic here is the deterministic post-processing. Because LLMs can be pretty unpredictable, right? Well, Skill3 doesn't just cross its fingers and trust the model to format things correctly. It mechanically enforces format compliance. It guarantees exactly one YAML front matter block, sanitizes the file name so it doesn't contain any reserved words, and makes sure the description is tag-free. The final output is a perfectly standardized SKL.md file every single time.
Finally, part 5, vetting for safety.
We absolutely have to talk about the trust boundaries here, contrasting raw data with the final output. Scraped page text from the open web, or honestly, even from a provided input file, is fundamentally untrusted data. A malicious page could totally attempt a prompt injection. Skill3 handles this by throwing up a massive, strict boundary between that untrusted web scrape and the deterministically sanitized, self-corrected skill that your AI agent actually consumes in the end.
So the crucial point is this two-sided vetting process. On the input side, before synthesis even begins, Phase 3A deterministically redacts secret-shaped tokens in place. That means a leaked key never even reaches the model. Then, on the output side, it actually integrates with NVIDIA's SkillSpector for local static security analysis. If SkillSpector flags an issue, Skill3 kicks off his self-correction loop, sending the draft back to the local LLM for up to 3 revision passes to fix it. And if high-severity findings are still there after all that, the run just halts completely with an exit 3. No way will it silently pass poisoned data. And you can actually build on this even further with the optional accuracy gate. While the standard pipeline is great at checking format and safety, you can opt into this verifier feature. It regrounds the entire LLM draft against the original sources in one single verification call. It actively strips out claims that the sources don't support, and it demotes future dated releases. It basically proves that this pipeline cares about strict truth just as much as it cares about formatting.
Look, the reality is your AI is frozen in time. That cutoff date, it's permanent. But with a tool like Skill3, its ignorance of the present doesn't have to be. You can bridge that knowledge gap locally, securely, and completely automatically. So, what skill will you teach your AI today? Thank you so much for joining me on this explainer. Keep learning and keep building.